What's up, First LEGO League Challengers, and welcome back to the FLL video series playlist for robot design and strategy. In this video, we'll be going more in depth on attachments, specifically what they are, what they do, and how to build them. So first off, what is an attachment? An attachment is a mechanism that assists your robot in completing a task. For example, if your robot has to move something to complete a mission, you would build some kind of hook attachment to allow your robot to move things around. All of your attachments will be attached to your robot base. During the build season, you will be grouping your missions together based on how close they are, what attachments they use, and other factors. We will be covering how to do this in a later video. The important thing to remember here is that all of your attachments will not all be on the robot at the same time. Your robot runs should end with the robot returning back to base, where you can swap out any of the attachments necessary for your next run. Attachments are essential to success as they enable you to do more missions. However, they must also be easy to remove and attach. This allows you to spend more time going for points during the game and less time swapping out attachments and redoing failed runs. There are two main types of attachments, passive and powered. Passive attachments are attachments that do not require the motors on your robot to be functional. They work based off of the robot's movement. LEGO pieces that stick out of the robot or rely on the robot's motion while driving are especially useful for certain missions because they can be pre-attached. This gives you a few extra seconds which can be used for runs instead of swapping out your attachments. Here's an example of a passive attachment. On the front of the robot, we see a huge arm. Let's see what it does. The robot starts moving forward and uses the arm to tilt the solar panels back. Notice how the arm itself did not move. The attachment relied on the robot's movement to work. Powered attachments work with the motors on your robot to move around. As we've mentioned in previous videos, the motor you use for your powered attachments depends greatly on what the attachment is for. For attachments requiring precision, use the medium motor. For attachments requiring more strength, or attachments that do not need to be that precise, use the large motor. Here's an example of a powered attachment. This time, there is a forklift attachment on the front of the robot. The robot drives forward, but notice how this time the forklift moves on its own. It comes down, pushing down the button and successfully moving the crane. This is a powered attachment as it had to work with one of the motors to be able to move independently. Now that you understand the basics of attachments and what they are, pause the video here and come up with a few ideas for attachments for your game. Ideally, make sure that they are usable for multiple missions and they are also easy to add and remove from your robot. Now let's test your understanding of passive versus powered attachments. Here's the first attachment. It's at the front of the EV3 brick and looks like it could be used to move things around. Remember, when determining whether an attachment is passive or powered, always check to see if it's connected to a motor. If not, it's passive. If it is powered. You'll have 15 seconds, starting now. Five, 4, 3, 2, 1. Time's up. This was a passive attachment. We can tell it's a passive attachment because it's not connected to any of the motors on the robot. Here's your next attachment. Remember what we discussed about determining whether an attachment is passive or powered. You'll have 15 seconds, starting now. Five, 4, 3, 2, 1. Time's up. This was a powered attachment. We know this because of two reasons. Number one, the arm acted independently of the robot's movement. This means that it doesn't matter where the robot goes. The arm will always lift up and down on its own. Second, we can also see wires leading from the arm to the robot's motors. This means that it is working with the robot's motors to move up and down. Thanks for watching. Be sure to like and subscribe as this helps other FLL challenge teams just like you find our videos so that they can get the support they need. Special thanks to FLL teams RoboKids and Alpha Betas, as well as Mr. Hino Robotics on YouTube for letting us use their clips.